Okay, fantastic. Y'all see my work screen here? Yes, you need to be vocal because I can't see you. Yay! Okay, the first thing I want to touch base with is this idea of amplitude. Can you remind me, visually speaking, what is amplitude? How high it goes. Can you be more specific, Johan? Okay. Can anybody else be more specific? Is it the highest point? Is amplitude equivalent to max? Okay, so how the function is stretched. So let me go back to my question. Is amplitude the same thing as the maximum value? Okay, good. It is not, right? Amplitude, so let's see if this is stretched. Well, on the y-axis, we'll put 4 and -4. If I have a sine function that is stretched this way, oh, ain't that beautiful? The maximum value is 4, and the minimum value is -4, or, wow, that's very off, but you go with me here. The amplitude is the distance between the max value and what we're calling here, in this case, the x-axis. This is called like the midline. And we'll talk a little bit more about that tomorrow when we talk about phase shift. But that distance is the amplitude. Okay, so the distance from the max to the midline here is 4, and the distance from the midline down to the min is also 4. So amplitude is just how much it is stretched from the midline on both sides. Does that make sense? Okay, good. Thank you for being vocal. The next thing I want to recap is remembering that, well, we'll do it actually when we do this next problem. Okay, on your homework. So, you may want to, did I not cross my A there? Okay, on your homework, on the back side, I want to do question 8A with you. 8A. And before we start using your calculator, I'd like you to clear your calculator. So second plus 712, go ahead and clear the memory in your calculator so that it defaults back to the original numbers to everything. And once you get it defaulted back to normal, the function for 8A is y equals 3 times the sine of 3 theta. Now, your calculator, when we input stuff into the y equals section, your calculator is understanding x's as your inputs. So in the y equals section of your calculator, you're actually going to type in y equals 3 times the sine of 3x. So after you clear your calculator, go ahead and the x value is inside along with this 3, the sine of 3x. And while y'all are typing that in, I'm going to sketch out an x and a y axis to match the one that's on our paper. Was that a yawn? Ooh. Oh no. It's okay. Did any of y'all watch Friends? One of my favorite things that Phoebe says is her phrase of "oh no." Hey, just FYI, y'all's vocals, and my dog's vocals, are being recorded, and this class's audio and my notebook here is going to be on my webpage for people who were absent today. So don't say anything that, would be deemed something you wouldn't want on the internet. Hi, outside people. Great. All right, here we go. Before we graph it, I want to answer the What is that? Up to 3. I want to answer the algebraic questions first. All right, focus, focus, focus. You with me? Okay. The algebraic stuff says state the amplitude and the period. So the thing that you need to remember is I'll say the general form, so to speak, of the sine function is y equals a times the sine of k theta. Okay? This guy is like the standard form, if you will, of what we can expect to see when we see our trig functions. Now, amplitude is what part of this, algebraically speaking? A, right? Particularly more than just A. Was that Miles? More than just A. What if that A were negative? There it is. Amplitude is the absolute value of A. So in our particular question for graph 8, part A is 3. So that means the amplitude is the absolute value of 3, which is 3. So the distance from the midline to the end points, if you will, for the maxes and the mins is 3. Now, the period, visually speaking, what is the period of a graph? Visually speaking. Yes, keep going. How long the entire... There you go. So how long it takes for it to complete one cycle. Visually, that's what a period is. Algebraically, how do you find the period of a trig function? It's not just k. No, good guess. That's it. 2 pi over k. So k is the number in front of theta. So in our particular question, what is k? The other 3, right? So if k is 3, then that means our period is going to be 2 pi over 3. Now, what is the typical period of a sine function? 2 pi. So now we're going to get through one cycle of pi, but in 2/3 pi span of time. So this one's going to have a lot higher frequency, and we're going to see a lot more waves in between 0 and 2 pi than we normally would. Okay, so we're going to graph this thing. So what I want you to do is in your calculator, you already typed it into the y equals section. Go ahead and peek at the graph and see what your sine function looks like. And it should be a lovely little wave that spans, across your entire graph on the x-axis. Am I right? Okay, now go ahead and look at your window. Tell me what the window says. What numbers you got? Okay, fantastic. So here's the issue. If you're going to try to graph this on the axis that I've provided you with, the x-axis is not counting by normal integers like 1, 2, 3, 4, 5, and all the way to 10, right? It's counting by radians. So what we want to do in order to graph this, in order to use the calculator to help you graph this, is that we want to change our window. Okay? So we want to make our window in the calculator match the graph grid that I provided you with on your paper. So if you're looking at the grid on your homework paper for number 8, part A, what is the minimum x value on the picture? Close. Negative pi over 4. So that's what you want to put in as your x min is negative pi over 4. And guys, this is what I would go ahead and write in your notebook in case you forget how to change these things. Okay, in your actual calculator, when you put negative pi over 4, make sure you use the pi button. Don't use 3.14. And you'll notice when you scroll away from it, it's going to change it to a decimal. That's okay. Your calculator is going to always kind of default back to the approximation. Now, what about x max? What's the biggest x value? 2 pi. So go ahead and put 2 pi as your x max. And then for the scale for the x's, Again, it doesn't make sense for us to have, 2 pi as our max value and count in increments of 1, 2, 3, 4, 5. So what is the grid counting by on your paper? Pi over 4. Fabulous. So go ahead and put your scale as pi over 4. So the x's are the ones that are a little bit complicated. The y's are a lot more clear. What is the minimum y value? There it is. And the maximum is positive 6. And so it kind of makes sense, those are dealing with integers. It kind of makes sense that these would just be at a scale of 1. Yes, you mean if your calculator does it? Yes, it will automatically. I don't know. Does anybody, Esteban, your calculator's fancy. Does your calculator leave it in terms of pi or does it convert it to the decimal? Yeah. There has to be a software that leaves it in terms of pi. I don't know. Okay, so that's good. Now if you look at your graph, so now hit the graph button and look at your picture, do you see how it is the exact snapshot window as what your picture shows on your homework? So now it's going to be a lot easier to match the graphing calculator picture to your grid that I've provided there for you. The only other difficult part is that if you actually wanted coordinate points to help you graph it, if you hit second table, so let's go look at our table. What are your x values counting by in the table? 1s. Again, that doesn't make much sense because our x-axis is not counting by 1s. What are we counting by in the x-axis? Pi over 4s. So here's the next thing you want to do. After you change the window, you want to change your table set. Change table set. So the key presses for that, you're going to hit seconds, and then the table set is just the window button. Just make sure you hit second before. And so you got two things. For table start, that's just where do you want, your table to start. It's fine to leave that at 0. Okay, but what about delta table? What is delta? Changing, right? So it says, it's basically saying, what do you want your x values in your table to change at increments of? Thoughts? Yeah. You want your table sets, you want your change in the table x values to match your x scale. Because if those match, then that means in your table you can match them directly to your tick marks along your x-axis. Okay, so you want those guys to match. Now, people have asked, oh, so I just need to remember what this table, what the window is in the table set is and use this all the time. The answer to that is no. You need to make your window and your table set unique to whatever particular problem that you're working on. And it's all going to be dependent on the graph that is given, or the grid that's given to you, and what you need to see for that particular problem. Okay, so all of this is to just match the picture. Any questions so far? Should I take your silence as a no? Yes, no questions, right? Okay. All right, now what I want to do is we want to go ahead and actually graph our curve. So, two things. Go ahead and look at your picture. Remember, your picture should match exactly as the one on the calculator. How many maximum points do you see on the calculator? 3, right? And then there are what? 1, 2, 3, 4 minimum values that we can see. So we need to make sure our curve matches that. So now what we're going to do is now hit second table. And now if you look at your x values, the x values are counting by pi over 4. So they should be a bunch of crazy decimals. Yes, is that what y'all see? Okay, so in your table, now this is not table set. This is just your regular table, second graph, hit your table. Your x values are like 0, 0.7854, 1.5708, etc., etc. Is that right? Okay, I want to go through the table and I want to graph the good numbers. I want to graph numbers that are exact. We know where they are. So obviously 0, 0 is a great one to graph. So let's start there. Now, again, as you move through your table, those are increments along your x-axis. So 0.7854 is what number on your x-axis? Pi over 4. Now, that y value at that point is 2.1213, and we don't really know where that is, so I'm going to skip that for now. Okay, 1.5708 is the next tick mark, which is pi over 2, which has a y value of -3. So that's a good looking one, so we can graph that one. The next one on your table, 2.3562, has another weird y value, so I'm going to skip it. Then 3.14 is pi, and again, we're back at 0. Then 5 pi over 4 is another weird -2.121, so we'll skip that one. Then 4.7124, which is 3 pi over 2, is up to 3. 7 pi over 4 is another weird decimal. And then at 2 pi, the coordinate is 6.2832. My y coordinate says 6e -13. Does anybody else say that? What does that mean? Okay, so it's like 6 times 10 to the -13th power, which is just super, super, super close to 0. So here's the issue. If I make a curve, a sine curve, between these 5 points, it's not going to look exactly like the picture does, right? A second ago, you told me that there were 3 maximum values in the picture. If I tried to make a curve with the given points that I have here, I'm only going to have 1. So the issue is that because my period is 2 pi over 3, I have a lot more coordinate points between these 5 points that aren't exactly on the grid. So we need to just estimate where these points are. You with me? Here's where I lost people in earlier classes. The way that you get these other points is just to estimate based on your picture. So hit the graph button and I want you to have the picture of the graph next to your paper, and all we're going to do is go through and we're going to follow the curve and estimate where our other points should be. And I'm going to use a different color so you know I'm getting these points elsewhere. Okay, a little bit to the left. Do you see how I have a minimum value a little bit to the left? At the very far left of the screen? It looks like it occurs just before negative pi over 4. So I'm going to put that minimum value at -3 just before the pi over 4 tick, negative pi over 4 tick mark. Okay, now I don't want you to follow every single point on the grid. When you graph, I only care about zeros, mins, and maxes. That's all that I care about when you graph. Zeros, mins, and maxes. Okay, so like pi over 4, I'm not going to have a point there because I don't have a 0 or a min or a max. Where does the max appear to occur? The first max that we see on that picture. Okay, on the picture that you're handwriting, yes, that's this one here. That is the max. But our first max on the calculator looks like it occurs just before that pi over 4 tick mark. Do you agree? So I'm just going to estimate a max is somewhere up there, just before pi over 4. Then we're going to keep following along our curve. After that max, then I have a 0. That 0 occurs between pi over 4 and pi over 2. About there. Then you keep following the curve, and at pi over 2, we already have that minimum. And then it loops back up again. And then we have a 0, it looks like between the second and the third tick marks on the x-axis. So somewhere about here is my next 0. Okay, then we keep going up. Then it looks like I have another max just after the third tick mark. about here. And then we go back down and we have the 0 at pi already. So then we keep going down, following the curve. We have another minimum between the 4th and the 5th tick marks. So about here. Loop back up, we've got another 0 between the 1, 2, 3, 4, 5th and 6th tick marks. And then we've already got that max up there at 3 pi over 2. And then we have another 0 between the next 2 tick marks. And then we have another minimum after that last tick mark that we can see in the picture. So these blue coordinate points that I just drew are just estimations based on what we can see from the picture in the graph. And so once you do that, you can go ahead and connect them. And this should be more of what your picture looks like in the calculator. Okay, can I answer any additional questions? You mean just figure out a different way to do it? I mean, you could, Allison, you could plug in these numbers by hand and figure out what the values are, or you could have graphed every point in the table. But the problem is the table didn't give you the mins and all the mins and the maxes because they occurred at other increments other than pi over 4. Okay, same thing, computing them by hand, you would just have to plug in your, other x values other than pi's over 4 to try to figure out where your maxes and your mins are. So after you get those initial 5 red coordinates from the table, all of the other ones in between, it's just going to be easier to gather them by estimating from the picture. Okay. All right.